Hello everyone. Today I'm going to give you a video tutorial about linear first order differential equation. Now, you have to familiarize, if you can, the following solution process. First, put the differential equation in this form. dy over dx plus a function of p in terms of x times y is equal to q of x. Second is find the integrating factor. V is equal to the integration a to the integration of px dx. And next is multiply everything. Multiply everything by differential in the differential equation by v, and verify the left side becomes the product of the rule of like this. V times the dependent variable y, like that. So that means we have to multiply by v the following equations, and then we have the product rule of this, like this. The integration of, that means we have this following equation next, and like this, and the q of x times v d of x. Okay, like that. And finally, we integrate both sides, and finally we solve for the solution. Solve for the solution. Okay, example. This is found in the page 35. Page 35, number 13. This is number 13, and the direction the problem is find the particular solution of each of the following equations which satisfies the indicated conditions. So I have just to solve one equation, which is this one, is number 13 on page 35. The same book. There was the book of Ray Wiley. It's the Advanced Engineering Mathematics. Now, we will use linear first order differential equation in this differential equation. So, the solution, okay. This is in the equation. We note earlier that y prime is equal to dy over dx. That's y is equal to a to the x. And however, this equation is already in this form. Well, congratulations to you. And next, second is find the integrating factor. Solve for v. So our v here is equal to a, which is our p of x, which is in this, is equal to 1 dx. That means we have a to the x. This is the first rule, the second rule, and the third rule is multiply both sides. That means from the original equation plus y equal to e to the x, and multiply everything by v, which is our v is equal to e to the x. So what happened is we have e to the x dy over dx plus e to the x y is equal to a to the 2x. And then by using this formulation, that means we integrate the derivative of our v, which is a to the x times y. Okay, so take note that this derivative of this from this equation here must be equal to this one. So that means the derivative of e to the x times y, that means the product rule, e to the x times derivative of y is equal to dy over dx plus y times e to the x. Okay, so that's right. So equal to the integration of a to the 2x dx. So this is, just cancel this out, that means ax times y is equal to derivative of this is e to the 2x over 2, right, plus c. And then, so this is our our answer to this. That means our solution. But yet we have to satisfy this following this indicated condition, which is our y of 0 is equal to 2. That means so we have to simplify this just in terms of y. Okay, so we divide everything by 1 over e to the x. So what happens is y is equal to a to the x over 2 plus c to a to the negative x. Okay, so since we have this condition, y of 0, which is equal to 2, is equal to this equation, a to the 0 over 2 plus c to the a to the negative 0. Okay. So this is 2 is equal to 1/2. This is c over 1. Because if we are to over this to c over e to the negative x, that means e to the 0 is equal to 1. So solve for c. C is just equal to 2 minus 1/2, that is 3/2. So we have the value for c. Then, to find our particular solution or the final answer, we just substitute the value for c. So our final answer, to get the final solution, we have to substitute this to this. So our y is just equal to a to the x over 2 plus 3/2 a to the negative x. And to simplify it more further, though this is already a correct answer, but to simplify it more further, we have this. 2 a to the x plus 3 to the a to the negative x. So, this is our final answer. Thank you for listening, and God bless.